Alright, so what is degree of freedom? So degree of freedom, which is abbreviated to DOF, is the minimum variable required in order to describe an object in a space. So when I have an object in like 3D space, for example, then I need at least 3 different kind of variables, x, y, and z, in order to describe its position, right? So these kind of variables, the number of variables required, is called the degree of freedom. It describes how freely an object is in space or a plane. So not only the translation can, so everything that moves or almost every object has a degree of freedom. So not only the translation or the position of an object, it also describes its degree of freedom. The rotation, it also describes the degree of freedom. So because the object can rotate, right? It can rotate on the x-axis, on the y-axis, on the z-axis. That's why we also need a variable to describe how it's rotating. And yeah, so it always describes how freely an object can move.
Alex, sorry, move into the...
Yeah, so in general, the more degree of freedom you have, it's easier for you to move around and do more complicated, different kinds of motions or positions. Because the more degree of freedom you have, it means that it's more free for you to rotate or translate or do different kinds of motions or positions. Okay, so I'll just give out a few different examples of degree of freedom. So, an object in 3D has 6 degrees of freedom, just as I said. Okay, so in the diagram here, you can just see how degree of freedom works. So imagine a head. So a head can move up and down, left or right, frontward and backward. So that's 3 degrees of freedom that describe its position in the 3D space. But it can also rotate. It can also do turning to the left, turning to the right. It can look up, it can look down, or it can just roll in like on the frontward axis, right? So you need at least 6 different kinds of variables in order to describe how a head is positioned in the space. So that's why we say that an object in 3D space has 6 degrees of freedom. So a point on the line. Okay, so a point on the line has 1 degree of freedom because on a point on the line, you only need 1 variable to describe its position, right? So you only need one. So a point on the line has only 1 degree of freedom. An example of it will be a train on a straight track. So you only need 1 variable, the distance, in order to describe where the position of the train is. It can't rotate, it can't go up or down, it can't go left or right, it can only go straight ahead. So we say that a train has only 1 degree of freedom. So an object on a 2D plane can have up to 3 degrees of freedom. So let's say, just look here. So let's say I have this object on a 2D plane here. So it can move front and back, it can move left or right. So that's 2 degrees of freedom. But what it can also do is it can also rotate on this axis in here. So if I need to describe this object, I need at least 3 degrees of freedom. Like 3 variables. So we say that this object has 3 degrees of freedom on a 2D plane. So I'm going to do a very small demonstration. Yeah, so it can do a translation, it can do a rotation. So our mechanical arm, the one that we just built, has up to 4 degrees of freedom. We need at least 4 variables in order to describe how the mechanical arm is positioned. So you know that our mechanical arm can move frontward and backward, and it can rotate to another angle, right? So that's 3 degrees of freedom by its own. And we also need 1 more variable to describe how it's open, like if it's open or not. So that requires an extra degrees of freedom. Okay, so now we're going to talk about a degree of freedom in a mechanical system, like a robot or in a mechanical arm. So it's easy for us to visualize how much a degree of freedom is there for 1 single robotic arm. But what we're going to talk about next is like robots and different kinds of systems. So the degree of freedom of a system is just the sum of degrees of freedom of individual parts. If we think about a robotic system of 2 of our mechanical arms, we need 2 sets of different variables because each arm moves independently, right? So we need up to 8 variables in order to describe both of the mechanical arms. So the total system has 8 degrees of freedom. So you can just think of, in robotics, you can just think of degree of freedom very simplifiedly as the number of motors you have. Because for each motor you added, you need an extra variable to describe how much the motor is rotating. So because our mechanical arm has 4 motors, we can just simply say that it has 4 degrees of freedom. So that's a really easy way to understand degrees of freedom. So in some of the humanoid robot, it can have up to 17 degrees of freedom because it has, because just look at these kinds of humanoid robots in here. It has 17 17 motors. 17 motors. So because for each motor it's independent and it can move, we need 17 different variables in order to describe its position and its movement. So we say that it has 17 degrees of freedom. So our hand has up to 27 degrees of freedom. So our fingers have 4 degrees of freedom, our thumb has 5 degrees of freedom. And our hand itself, its position and its rotation, it gives us extra 6 degrees of freedom. So we say that our hand has 27 degrees of freedom. That's why robots is very hard to mimic our hand, because our hand is so effective in doing different kinds of motions, different kinds of positions. Let's say this kind of robotic arm in here. It's really effective in grabbing or doing different kinds of translation, moving, but it can't do something like a fist bump or counting or clapping, for example. It can't do like position like these or these or these. You need different kinds of joints. You need a higher degree of freedom in order to do what our hands do. So that's why robotics so far is finding really hard for us to mimic our hand. So that's the end of my presentation. Is there any questions for you want to ask about this video? Yes?
Yeah, you mentioned about like fingers having 4 degrees of freedom and some having 5.
Yes.
What's the extra one?
So for thumb, you have 1 degrees of freedom for your first thing. You have the 2nd degrees of freedom in here. You have your 3rd degrees of freedom in here. You have your 4th degrees of freedom in here, because this lower part also counts biologically as a thumb. So this part in here has 2, this part in here has 2. And the thumb here itself has 2. Has 1, sorry.
Oh, okay.
So that totals adds to 5. And fingers, you can do 1 degrees of freedom in here, the 2nd degrees of freedom in here, the 3rd degrees of freedom in here, and then you have the 4th degree of freedom in here.
Okay. Oh, that makes sense. Okay.
Is there anything else?
Emma? Any question, Emma?
No?